Hey folks, this is Mrs. Sid. Wish I could be there with you, but now my daughter is sick. She has the flu. So I'm home with her today, and you are getting notes through a video. I know this might bring back a little bit of bad memories from the last couple of years, but I promise I'm going to stick to two topics, one of which should be a little bit easier, and the other we will practice and practice and practice in class. So don't disheart if you're like, Mrs. Sid, long division by myself. I remember I'm here. And even though it might seem hard, you can do it. You are a smart person and you are going to be able to figure this out. And if not, you will get help. So here we go. Let me get started with our slides. You should have a blank copy of our slides for today. So hopefully you're listening to this with your earbuds. So let's go to the first idea. So the first idea asks, is there an x-intercept between -1 and 1 for this particular polynomial? And I mean, looking at it, you're like, maybe, maybe not. I don't know. I don't want to factor that because it's an x to the fifth and then an x to a squared, and there's a 7 and a 5. How in the heck, what am I supposed to do? So there's something in mathematics called the intermediate value theorem. And here's how it works, and then I'll explain to you exactly what the theorem is. So first, let's actually do f of -1. So f of -1, actually, let me switch that color. Not a big fan of writing in red. All right. F of -1 is 5, and then times -1 to the fifth minus 4 times -1 squared plus 7. Okay, so that's 5 times -1 minus 4 times +1 plus 7. So we're getting close. -5 minus 4 plus 7. Well, this is -9 plus 7. So that's -2. Okay, so this gives me the point -1, -2. Excellent. So now let's do f of 1. And then I'll swing back to why and how can I tell that this is going to work. So f of 1, so I'm putting in 1 again for x into the original function. And this is going to be a little bit easier because I get 5 times 1 minus 4 times 1 plus 7. So 5 minus 4 is 1, and then if I add 7, I get 8. Okay, so this gives me the point 1, 8. Now again, you might be thinking, how in the heck does that help? Well, let's just think about this. If I plot these 2 points, so there's -1, -2, roughly there, and then 1, 8. The question asks, is there an x-intercept between these two x values? Well, there must be, because the only way these 2 points can connect is if we cross the x-axis somewhere. So I'm going to say yes, there is an x-intercept because the y value went from negative to positive. It switched signs. And that's really the heart of the intermediate value theorem. It basically says that if the y coordinates switch, there must be at least one x-intercept. So let's take us to our next slide. And here's the mathy way to actually say all that. If P of A and P of B are opposite signs for some real numbers A and B, then there exists at least one real zero between A and B. So let me just kind of draw again what we were just looking at. If this is A and this is B, then what we're looking at here is that if this is P of A and say this is P of B, this polynomial must have crossed the x-axis at least once. Again, it may have done zigzags through here. There might be more than one real zero, but there must be at least one. And that's the intermediate value theorem. So it's not as bad as it maybe sounds. On to long division. Oof. I bet in elementary school when you saw this, you were probably like, when will I ever need this again? And here it shows up senior year or junior year for some of you in your math class. So we're going to do long division of polynomials, but in order to do that, we kind of have to either relearn or learn for the first time how to do long division of numbers. I have had students over the years tell me that they've never learned how to do long division, which is fine. So if that's you, know that here's your opportunity to learn something new. Okay, so let's talk about what in the heck do we do here. So we're dividing 15,621 by 30. So I know that 30, the 15 isn't going to work. I have to look at the 156 or the 156. So 30 goes into 156 5 times. Maybe I should switch colors here. It goes in here 5 times because 5 times 30 is 150. I subtract that result. So 1 minus 1 is 0, 5 minus 5 is 0, 6 minus 0 is 6. So it brings down the 6. Okay, I have to bring down the 2. And now I have to think, how many times does 30 go into 62? Well, 30 goes into 62 2 times. So 2 times 30 is 60, and if I subtract that, I'm left with 2. Okay, then I have to bring down the 1 because 2 is too small. And I then kind of look at what I have and I go, oh, shoot, 21. Well, 21 is smaller than 30. So perhaps back in the day, you would say something like, this answer is 52 remainder 21. I apologize for that terrible writing there. Let's see if I can fix that. And you would kind of be done. Now I know as you went up in elementary school, you might have said that this is 52 and 21 30ths. That was another way you would talk about the remainder. For what we're doing with polynomials, I'm going to be okay if you did 52 remainder 21, and remainder can be abbreviated with the R. Now, at this point, if your head is spinning, make a note to yourself that you might want to go look up some videos on long division of numbers. It might help because long division of polynomials is going to follow this pattern. So let me flip to the next slide, and here we have an example. Okay, so let me talk my way through this. Oftentimes when I do this first example, from the onset, students freak out and they're like, I don't get it, I don't understand. And then after they see me go through it, they feel better. So if your anxiety goes up, just take deep breaths. You will be okay. You will understand this and follow it through. Luckily, this is a video. You can replay it. All right, so let's get started. So we have x plus 2 on the outside, and it's dividing this 4th degree polynomial. So I'm looking really at the x. The 2 is not going to be super important to me. It's really the x. The fact that I have a binomial there means I'm always going to want 2 terms. So the first question I ask myself is, x times what is going to cancel out that x to the 4th? Well, x times x to the 3rd will cancel out that x to the 4th. And here I start multiplying. I'm going to do x to the 3rd times x. And then I'm going to do x to the 3rd times 2. Just like with the numbers, I'm going to subtract the quantity. So that felt much easier to do with numbers. This feels a little bit more wonky. So x to the fourth minus x to the fourth, that's 0. I'm not going to write it, but it's 0. And then I have 5x to the third minus 2x to the third. Remember, this minus has to get distributed. So this actually becomes 3x to the third. And then because I have two terms out here, I have to bring down that 6x squared. Now let me switch colors. And now I'm going to start that process all over again. So I ask myself, what do I have to multiply x by to get 3x to the third? Well, I need a 3x squared. 3x squared times an x would get me 3x to the third. 3x squared times 2 will get me plus 6x squared. Now, this is looking awesome. When I go to subtract, I actually get 0, right? Everything sort of cancels out. But I have more terms. So instead of just dropping the negative x, because I have two terms out here, I also need two terms here. So I'm going to drop them both at the same time. And I'm going to switch colors again so you can see the next step. Okay, I'm going to repeat the process again. I'm looking at what I can multiply x by to make it a negative x. Well, I'm going to have to multiply it by a negative 1. So negative 1 times x is negative x. Negative 1 times 2, negative 2. And as you can probably already see, when I subtract that, negative x minus negative x, so negative x plus x will get me 0. And negative 2 minus negative 2, so negative 2 plus 2 is also 0. So my remainder here is 0, which always feels really good. We're going to want to do that a lot. We're going to want to get remainder of 0. Right now, long division is going to, we're just looking at it as, can you do long division? We'll talk more when we're together later in the week about how we're going to use this for a tool with our polynomials. Okay, so let's try another example. And it, of course, has something just a little bit funny and off, but we'll deal with that together. Okay, so the 2x minus 1 is on the outside, because that's what I'm dividing by. And then underneath, I'm going to put the 2x to the third minus 7x squared plus 3x. And then I'm missing the constant term. So I'm just going to put a plus 0 as a placeholder. So I have a 3, a 2, a 1 exponent, and then like the constant term. Okay, so that's kind of a new little twist. If this, say this was just a 3, I would have added a 0x before the 3. So just kind of different ways that these problems can show up and have little pieces to them that feel a little bit different. All right, so same process. I ask myself, 2x times what will get me 2x to the third? Well, 2x times x squared. So x squared times 2x is 2x to the third. X squared times negative 1 is negative x squared. I'm going to subtract the quantity. The 2x to the thirds cancel each other out, and then I have negative 7 minus negative 1. So it's like negative 7 plus 1. So that'll be a negative 6x squared, and then I have to bring down the 3x. Okay, and then let me switch colors so you can see that it's a new step. So I ask myself, what times 2x can get me a negative 6x squared? Well, 2 times negative 3 will get me the negative 6, and then x times x will get me the negative, or get me the x squared. So let me see. Negative 3x times a positive 2x should give me negative 6x squared. Negative 3x times negative 1 plus 3x. Oh, and notice we have another jackpot. Remainder 0, we don't need to worry about bringing down that placeholder. So we're just happy that it's all done. Now, perhaps this is a time you want to pause the video and kind of see, can I do the next one on my own? So if you feel like you might want to try a step or two, I'd say go for it, pause the video. If not, let's take a look at this one together. All right, so here you see placeholders. We definitely need placeholders. So x to the third is there, but there's, oh no, there we go. There's no x squared. There's no x term. So I'm putting a 0x squared and a 0x and then minus 27. Okay, so placeholders abound. Let's take a look. Let's dive in. What times x gives me x to the third? Well, x squared does. So, oh shoot. I was saying x squared, so I wrote it. X squared times x is x to the third. X squared times 3 is 3x squared. By the way, spoiler alert, we will have a remainder here that's not 0. So it's unfortunately not going to divide evenly. So let's subtract. Those cancel. So 0 minus 3 is a negative 3x squared. And then I'm going to bring down that 0x. 2 terms on the outside. I need 2 terms to divide. Okay. So now I ask myself, what times x will give me negative 3x squared? Well, a negative 3x. So negative 3x times x is a negative 3x squared. Negative 3x times positive 3 is a negative 9x. All right, I'm going to subtract the quantity. So the 3x squareds are going to cancel, and I get 0 minus a negative 9x, so that's plus 9x. And then I'm going to bring down the 27. Okay. So I now ask myself, what times x will get me 9x? Well, 9. So 9 times x, and then plus 27. Remember, I'm subtracting this quantity, which seems like it should cancel out, but be careful. Negative 27 minus 27 is actually negative 54. So we do get a remainder here of negative 54. For right now, I just want you to note that you got a remainder. Not a big deal. Just write it like this and move on to the next problem. All right, so a little bit harder, right? Because we're not dividing by a binomial, we're dividing by a trinomial. But long division still works the same way. By the way, those of you that really dislike what we're doing, there will be a slight shortcut for binomials when you divide by a binomial. So the shortcut wouldn't work for this one. Okay, one thing I notice is that I don't have an x squared here, so I'm going to put in that placeholder of 0x. And now let's get started. So just like the binomial, it's really the 6x and the negative 7 aren't going to matter too much when I'm deciding what to put up here. I'm really focused on that x squared. So what times x squared gives me x to the third? Well, x. So x times x squared is x to the third. X times 6x is 6x squared. And x times negative 7 is negative 7x. All right, let's subtract. Those cancel. 0 minus 6 is a negative 6x squared. Negative 43 minus a negative 7. Oof. Okay, so negative 43 plus 7, that's going to give me a negative 36x. Oh, it's interesting. Okay. And then I only have 2 terms here, but I have 3 out here. So I'm going to drop the 42 so that I have 3 terms. Okay, and then I ask myself, what times x squared gives me negative 6x squared? Well, that's a negative 6. Negative 6 times x squared is negative 6x squared. Negative 6 times 6x, negative 36x. And negative 6 times negative 7 is plus 42. We luck out. This one cancels out completely, and we have a remainder of 0. Yay! Like I said, it'll be nice when we're using this as a tool to get a remainder of 0. What that tells me is that that x squared plus 6x minus 7 is a factor of the polynomial it's dividing. So that will be important when we are factoring polynomials. All right, so that's our last slide here. The homework is 3 problems long. 2 are long division. 1 is about the intermediate value theorem. I really hope to be back with you folks midweek, but please get help if you need to at the AAC on Tuesday. And like I said, I hope to be back with you on Wednesday. Remember, you can do hard things. You can do this. You've got this. All right. See you later, folks.